Welcome to the slop farm. Enjoy the video.
You begin by validating network-level prerequisites and getting the headset tied into the 5G path. Check that your carrier offers a low-latency slice or MEC node near your region, because that's what reduces RTT. Once you have that, attach the XR device via native 5G or a local 5G hotspot. Make sure your link supports sustained uplink. At the same time, start slimming assets, lower poly meshes, 1/2 textures, and basic LOD and culling rules so rendering stays within budget. Now you configure the streaming and synchronization pipeline so interactivity feels immediate. Set adaptive bitrate with quick codec switching and aim for at least 60 frames per second. This keeps motion smooth. Use head pose prediction and small jitter buffers between 50 and 150 milliseconds so frames arrive in time. Offload heavy tasks like physics, occlusion, and scene reconstruction to the edge server, and use UDP with forward error correction to tolerate packet loss. Finally, finish by validating performance and baking in robust fallbacks so the experience never breaks. Conduct end-to-end measurements for round-trip time, frame time, and packet loss, then tune buffer thresholds and bitrate policies based on real numbers. Implement auto fallbacks that reduce resolution, switch to local rendering, or disable non-essential effects when the network degrades. If things go wrong, examine logs and remote profiles to identify whether the bottleneck is CPU, GPU, or network. Often a quick fix is switching to the MEC endpoint or increasing FEC on the stream.
Thanks for watching. Consider subscribing if we helped you today.